going live. This is okay. I have been attempting to define, hit ground zero for the Pscale. So the thought: why can't I arrange that location of the window? I don't get it. I do not get it. Edit, customization. No. Is it this one here? Channel level settings. Probably not. No. Pop out dashboard. What's that? Okay, it's useless, right? It's just basically reaffirming that there is nobody actually watching. Thank you for that. Wait a minute, there's a camera picture here. You don't have access to this feature. This is YouTube. I mean, this is like, multi-billion-dollar company, blah, blah, blah. And I can't even move this window. It's just stuck like a blob at the bottom of the screen. God damn it. Right. Apologies for the this is the technology that we are dealing with. So what I've been attempting I wonder if we can share this. Let's put this, add this publish artifact, and then we'll look at it online. Shall we do that? Yeah, let's do that. So this is an easier way to see it. Bosh. So basically we have a document which is this, and all the blab for this hopefully will be contained in a nice explanatory slide deck, which I haven't seen. I haven't even looked at this. Hopefully it contains I've had multiple discussions with Claude, and we've had multiple builds, and to the point where I've tried to reduce it down to a sea urchin agent. So we've got the hermit crab, which is quite large, quite chunky. And then the 2 is a starfish, which is meant to be some form of it. 3 is an ammonite. It's meant to be a smaller, simpler version of the hermit crab. And then the ultimate is the sea urchin. It's like, this is tiny. It can run on a phone. Okay, run on a phone, for crying out loud. Okay, or thumb drive. It runs on a thumb drive. Okay. And I'm talking about LLM. I'm talking about using web LLM or a local LLM, a local large language model, LLM, or I suppose it's medium, MLM, I don't know, right? And trying to come up with the smallest versions. And so this is an example, 118 lines of code for the test unfold for Python code. The kernel itself is 11 lines with 11-line touchstone. Okay, that's like it. 12 blocks is pure JSON data. 6 kilobytes is the touchstone. Wow. Okay, it's beautiful. So it's really small, but can it be smaller? And the reason why is because even with this one, with the sea urchin, right down to it, and it was like a kernel of 10 lines of code, traditional code, that unlocks or starts to trace the content in the JSON block in a certain way. So it's got to be able to know how to do that. And so it does it, and then it basically learns how to do something, and then it unlocks content out of the JSON block, which effectively becomes kernel, which then can do more on the JSON block. So we call it a coding block. Okay, it's not code. Okay, but it is used by a traditional library of language we understand as code. So JavaScript, all right, or Python. And that's a library, and a library of a lot of words that basically operate on just zeros and ones. Okay, with a computer, silicon. Whereas an LLM is doing some algorithm, and its fundamental is a token, and actually it's vectors, and it's doing mathematics with vectors. And that's its operating system. And it's basically a soup of vectors. And then it converts back into, here's a bunch of vectors in sequence that make some kind of sense. Somehow, magically. because of the pattern matching and the fitness algorithm, i.e. the evolutionary algorithm that it's using. And all I'm trying to do is allow an LLM that's currently operational and providing it with a JSON block and its kernel, basically, in associated with it, to do something different. It's a different tool, okay? And it's basically structured semantics. And so it's the touchstone. It's the touchstone between a normal, I'm going to call it a dumb computer, zeros and ones, calculations, and everything is predicated on logic. And content is on the outside. We have to apply language outside. And so we have these categories and we put content in it, numbers, and we're manipulating all that. It's called code. And it's just a variation of language, basically, but based on numbers and operations and basically logic, zeros and ones. And the logic gates for those, as opposed to LLMs. Associations, relations, what do you think of this? And it makes some kind of sense. And the touchstone is the semantic block, and specifically what we're about to share right now. I'm blabbing. What time are we in now? 6. So we're going to start this properly. Let's have a look at what this is. The touchstone between LLMs and structured memory. Wow. Okay, next. Oh, right. Okay, so it doesn't even have a... Okay, the Windows size is just a little bit too tight. I don't like it. I like to see the bottom of things. I like to see the bottom of things. How can I reduce this? I can't seem to reduce it. Who designs these things? Oh, for God's sakes. You have to think about this and just go, who in their right mind? Holy hell. Oh, God. Okay. It's just, oh, God, this is painful. This is painful. I'm literally attempting to grab it. Ah! I had to grab it on the screen below. Who would have thought? Okay, so Pscale block mechanics, the touchstone. So we're going to go through this and find out if it makes any sense. Okay. 0 to 9. We need to tidy that up. Look at that. There we go. 0 to 9. Customize. The touchstones between LLMs and structured memory. A data structure that describes itself. No schema, no metadata. An LLM reads it and knows what it is, how to navigate it, and how to grow it. This is the minimal system. There is no simpler version. Everything else builds on this. This is a fundamental. And I've been trying to get the fundamental a few times. Oh, look at that. That's so badly done. Oh my God. The slide, you can't scroll. Oh God, that's what happens if you deal with... if you leave it up to LLMs to work it all out. Right. So it's not bad. It's got a little indicator up here, how far we're going. Right. The block. 3 things. That's all. A Pscale JSON block contains only curly brackets, digital keys 1 to 9, and the underscore. No metadata, no wrapper, no type field, just these. What this block is about. Bang. The underscore maps to digit 0. 10 positions, 0 through 9. 1 level of nesting. That's it. Well, okay. Is it going to say anything interesting? Right. Okay. The underscore is inside the thing it describes. What this block is about refers to entries 1 to 9. It describes itself. But it is structurally a member of the set. Same nesting depth, same parent object, a sibling of the entries it names. The title of the book is printed on a book inside the book. This is the Mobius twist. Good. The Mobius twist. The set contains its own label. In Russell's type theory, this is a paradox. In JSON, it just works. Because our curly brackets enforce co-presence, not logical order. The simple twist is form 1, self-referential. The underscore describes its own group. Now, the significance of this as well. BSP, split the number, walk the tree. Take any number, split it into digits. Now, it's already jumped to this, and I think we need to have an explanation of 2 of these. Okay, so, but okay, let's see if you can make sense of this, or I can even. Take any number, split it into digits, walk the JSON 1 digit at a time. Digit 0 steps into the underscore. Okay, each step collects the digit, the text at that node. The chain of collected text, broad context, specific detail, is a spindle. 1 number, 1 traversal, 1 contextualized result. I think there's a massive jump between that thing. This is nice, and I think it should go to 2. I think it should go to 2 of them, and the relationship of how you connect them. Okay. It's gone off for the BSP. Okay, I think that's a bit too much. That's a bit too kind of like, it's a bit too much, right? The block is full. What happens next? Okay, right. Digits 1 to 9 are occupied. A 10th entry needs to arrive. The entire block wraps inside. It wraps inside a new underscore. Before, about this block, first, 9th, and then after the super nest. Okay, so it's nesting backwards. Okay, about this book, da-da-da-da-da. Okay, that's fine, right, 1 to 10, right. All original addresses gain a 0 prefix. What was 1 is now 01. What was 7 is now 07. Context changed, position shifted. Okay. Same key, 2 completely different operations. Form 1, single Mobius. Underscore describes its own group, self-referential. That's the one we just dealt with. Spatial mode, the keep, contains the kitchen, courtyard, stables. Digits, arbitrary levels, no sequence. 1 could be 5. Okay. The underscore names the container. It points downwards at what it holds. Form 2. Okay. Now, I understand this, but I don't think this is explaining anything to anybody. Okay, I think it's just a bunch of words. That's what I think. But, you know, I'm a teacher. There are some benefits for being a teacher in the sense of I know when things make sense or don't. When somebody's just yabbing, and you're just like, what are they talking about? As opposed to, I actually know what they're talking about. And you have to get the insider understanding. Okay, once you get insider understanding, then whatever it is that somebody's yabbing on about makes sense. And sadly, that's what insider understanding is. But that's actually what semantic numbers are. The semantics is within the number. Okay, but anyway, underscore summarizes the previous complete group. Backwards facing, sequential mode. Address 10 summarizes entries 1 to 9, which kind of makes sense. Address 20 summarizes 11 to 19. Digits are ordered 1 before 2 before 3. The summary faces the past while occupying a forward position. Okay, so the 20 is at the end of 1 to 19. Okay, but as you're growing 20, 21, 22, that 20 is not referring to the 21, 22, 23. It's referring to the previous lot, the 11 to 19. That's why this is form 2. It's a double Mobius. Same JSON, same bracket, same underscore key. The mode is determined by the content, not the structure. An LLM reads the words and knows which form is operating. Code cannot tell the difference. That's the difference between inside and outside. Okay, we're just going to have to widen this so that the text can actually fit on the same page. Crying out loud. Growing inwards. The decimal point emerges. Now, this was the new thing today, because I've been through this 2 or 3 times trying to get down to the fundamental. Coming up with the thing of the spatial, that's what happened first. Then it was the first version of Pscale, and then it was the second. And, you know, just the other day, it was the sea urchin. Okay, that was Saturday. That was a few days ago. And it was like, okay, let's really get down to the absolute bare minimum. And then we thought we'd done it. And here I am again, just going, I'm not convinced. I'm just not convinced. In the morning, I don't want to be thinking, I want to sleep. It was 6 o'clock in the morning. It's still dark. No. And if I fight it, it's not a good idea. Okay, so I was just like, okay. My mind wanders, seeing if I could just find something that just kind of takes me off to the shore, into the sea of swimming, into dreams, into sleep. But nope. It had to aggregate around, how does this work again? There's still something nagging me about how this works, and yep, sure enough, and I tried Claude Code, and then it just was too particular and just didn't work out. So I went back to Claude because there's enough flexibility, and we were approaching by language. It got it wrong 3-4 times. Look. You don't believe me? This is every time I engage. Okay, Claude. Okay, remember you're starting from the beginning, even though it does have a memory, and then it's got access to everything. Use case 1. Look, it's got decimal there. No, got rid of that. Tree. What is that? And this is meant to be use case 1. Single nesting level. And look, it's got 2 nesting levels. You're like, okay, look, no. Let's just start at the beginning. Okay, it just went waffle. And I went, no. Can we just start with that, please? That's what we want. That's so simple and pure. And then we tried, and then the 2 levels, just wrong. Look, it's just wrong. I mean, if you want to look at it later, okay, it's just wrong. And then I went, devise this. Oh, okay, it's come up with this. It's like, no, it's gone messy. No. Start with that again, please. And look how I'm thinking about it. Oh yeah, it makes some kind of sense. Okay, right, okay. Let's think about two of them. Oh, right, okay, let's think about two of them. The summary of 1 to 9. Okay, and that's 1 to 9. The 10th entry is in 2. No, it's wrong, it's wrong. It's like, oh God. And so basically, it just consists of a lot of things that are wrong. And then I go, okay, well, I think it's like this. This is how numbers appear to work. Blah, 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 blah. Anyway, so here we are. So, when an entry gains children, it grows deeper. Okay, most entries growing inwards. Wait, did we just do the past one? Okay, two completely different operations. Two forms of the underscore. That's growing outwards. Have we dealt with that? Yeah, okay, we dealt with that. Okay, now this is growing inwards. Okay, so this is when it extends inwards. So the 2, so 1 goes further. The depth that most entries share is the floor, the implicit decimal point. This is the floor. See, it's introduced, that's the floor. Why? I would go, right, so how do we know this? Okay, let's call that the floor. Okay, and it's kind of like, that's the way I understand things. It's like the explorative, how I manage to discover things. Whereas most people is they package it all and then they say, right, this is the explanation. But it doesn't actually give you the journey of how it came up with that. So it's the same with, like Newton. Newton came up with calculus. Okay, fantastic. And Leibniz. And they both came with calculus independently, apparently, or there was some kind of scripting going on between them. But they came up with different formal methods. Okay, we actually adopted Leibniz's method with integrals and things, differentiation, dy, dx, and all that kind of rubbish. All right, we've got all that. But how did they come up with this stuff? And if you look at Newton's method of how he got up with it, that made sense to me. So his method of explaining it with x and x dot and x dot double dot or something or other, I was like, oh yeah, okay, that makes sense a little bit. It's like x, not fully x, it's a little bit of x. Oh, okay, a little bit of roundabout x. Oh, okay. And so it made sense to me. So the actual methodology of scripting was a way for me to understand how he got through the process up to eventually getting to calculus. And so that's what I attempt to do when I'm sharing things with kids, and it works pretty well. Whereas most adults, they want a package. They just want, give me a block, give me another block, give me another block. Okay, and that's what I have to do, right? Block 1, block 2, block 3. Okay, I've got the pattern. Here's block 4. Yeah, okay, I understand. Okay, but what we're interested in is the creation of the thing. How do we even get any of these blocks to work? How do we even create one of the blocks? Oh, I don't know. I just got told them. Yeah. So, how do you use calculus? How do we even come up with calculus? I don't know. I don't care because I can use it. That's not quite good enough. And so we're dealing with an LLM. Okay. And so therefore, in every single instance, we have to deliver something such that it learns this and can start operating it because it's part of a continuity of the previous one that learned it and is operated it for this instance, for the next instance. So it's got to be a thing that they learn in that period of instance because it doesn't have any of this in training. This is completely new. Yes, it knows how to use JSON. It understands JSON in some kind of form or other, but using them as semantic numbers where the semantics is in the number, this is how you use BSP function in order blah, blah, blah. All of that needs to be taught and learnt by an instant within the context window of that instant while it's processing it. That's like seconds, okay? And that's why I've got things like, the different versions, the ammonite, the sea urchin, and so on, the hermit crab. And compiling that, so it looks like, do I have an example of it operational right now? No, I'm not going to do this now. I've just been fiddling out with it, so I don't even know if it's going to load, and I don't want to have that level of disaster right now. So this doesn't quite explain it. What do you mean this is the floor? The depth that most entries share is the floor. What? It's just, okay. And most adults will go, okay, so it's called the floor. Okay, right. Whereas I'd be like, why is it called the floor? What's this about? It's an implicit decimal point. It's just the wrong way of explaining anything for me, right? It just means that basically, see that underscore there, it's at the top level, and there's no sub. It's going to explain this later. So maybe I should leave it. Okay, let's leave it for a bit. Okay. But if this was a 2, and I would put this side by side, I would put the 1 and the 2 and the 3, and then I'd say, right, let's say we want to grow that into that details, and we put that on the side. Okay, so we have the 1 on the left, which is 1, normal depth, 2, normal depth, 3, normal depth, and then over here, we're going to put more detail. So it's growing, it says inwards. Okay, it's growing to the right. We called it, growing. Nowhere in our language, in our chat, did I ever use the words growing inwards. I mean, inwards. Why is it using inwards? I mean, who knows what associations are going on in the LLM to come up with that? Okay. So we call it sub-nesting. Okay, so we had super nesting, which is going, the entire thing is being nested, as opposed to sub-nesting. We go, let's create more nesting. Okay. So 2, we're basically going into detail. Okay, what about 2.1 or 2.2? That kind of thing. Super nesting shifts the floor down uniformly. The whole block swaps. Oh, okay, there you go. You just have to adopt these languages and just that's what it means. Subnesting creates local depth. One branch goes deeper while the rest stays level. That's the bit that's interesting. Okay, so if 2, you go, oh, okay, I'm just going to put a little bit more detail here. The problem is when this is read, that is going to be a 2 followed by a 1. That 2 is suddenly going to become 21. Yeah, that is 1 because there's no subnesting. This is 21. So the semantics for this 2, this also normal, is no longer also normal because it's now bumped up to 21. 22. Oh, yeah. Okay. Now what it's done is it's actually said, okay, 2.1. Why? And the reason why is because of that underscore has not got any other underscores with it. That's it. That's it. That's it. It's so beautiful, and I don't understand why this thing's waffling on about stuff. Count the underscores. That's the decimal. So it's kind of, it's presenting it as if it's like, oh, this is a new thing. Don't think about it. This is it. Just learn this and go off. I don't like that way of doing it. Count the underscores. Okay, that's the decimal. From the top of any block, follow the underscore key. Is it a string? Stop. Is it an object? Step into its underscore. Repeat. Okay, so this is meant to explain it. Unbelievable. I would have the actual an example with underscores going underscore, 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 underscore in the nested thing, and eventually you have underscore semantic, and then the arrow saying, look, here it is, here's the string. The underscore chain length is the decimal position. Correct. No metadata field required. The structure encodes its own originate coordinate origin. We were writing down a number we could have counted. What I see from the inside. I am a language model. Okay, so what are we on? We're on 8 of 9. Did that explain it to you? No. What I see from the inside. I am a language model processing this conversation. Here's what I observe. I have been trained in every tree structure, every JSON schema, every hierarchical data format that exists in public text. Tries, what does that mean? Trees? No, B trees, nested dictionaries, XML, YML, S expressions, Godel numbering, hierarchy namespaces. None of them have this property. A structure with the nested depth of a single key encodes the coordinate origin with the same format, supports different semantic modes readable from content alone, and where I am, an LLM, can determine the interpretation without any external documentation. The closest analogy is not in computer science. It is in differential geometry. Yes, a manifold that carries its own metric tensor. The block knows its own shape. And the division of labor is precise. I read the content and understand the form as the LLM. Code counts the underscores and walks the digits. Neither of us can do the other's job. This architecture was designed for the gap between code and language. It wasn't designed for that. It's just like, look, I've got this use case and I want to like play in a fancy world, and I've got this spatial world of keep, and in the keep there is like a kitchen, and in the kitchen there's a fireplace, and look, we can use numbers, semantic. Oh look, we can just use numbers. Okay, wait, can we use that for other process? Oh, we can use it for time. Okay, wait, can we use it for documentation? Oh yeah, 0.1. Okay, wait, is there a structure for this? Oh, okay. And then it's just a matter of exploring all the way down to floor 0, okay, which is what's the minimal possible structure, which is a kind of principle of maths. You're trying to get right down to the minimal, okay? And, and all the way through this process, it's come up with, oh, we have to put decimal as metadata, as you just saw. So no, metadata is, we're borrowing it from our current crappy system. No, just use nested. And it had that warp of the underscore, because zero is really wacky in our, I should have that about this. Zero is like an unbelievably wacky concept that took forever before Westerners, modern Europeans, picked it up. You know, the Arabs managed to stabilize it. The Indians were using it 2,000 years ago. But to have it zero, which doesn't mean nothing, it means precisely, in context, no tens, no hundreds. That's amazing. That's what needs to be here. It's like the zero here, it's not the same zero. It doesn't mean anything. It doesn't mean nothing. It means zero somethings. Okay. However, the actual numerical value of it is zero, whereas a 2 in 320 is different from 230. That's 20 sheep as opposed to 200 sheep. That's a completely different thing. Yeah. So the 2 refers to a completely different number, whereas 0 tens and 0 hundreds, guess what? You've got 0 sheep. It doesn't really matter. It conflates. That's the thing that conflates. And so similarly, so when we're doing with semantics, what the hell is 0 referring to? Oh, it means nothing. Well, what do you mean it means nothing? If it means nothing, there's nothing being meant. So how do we have a symbol for something that's nothing? Mathematics, we can do that. With semantics, we're not so good with it. It just means we don't know. We don't have any semantics for it. Oh, okay. So when we represent it in the this form, we don't represent the 0. We represent an underscore. It's only ever indicated with an underscore. And it has this Mobius quality. It's referring to the group of its own nesting or a previous nesting. All right? And that's the second level of Mobius twist, okay, to do compressions. All right? In order to basically fit into how we use numbers, 20 as a summary of 11 to 19. That kind of makes sense. Not 20 as a summary of 21 to 29. That doesn't make any sense. But it does when you're mapping it to spatial orientation, it seems. Okay, it does. It works. So it's very interesting. The whole thing is just so interesting. It's so amazing. It's so brilliant. But it comes down to this. Right. Division of labor. So basically, it's basically saying LLMs and computers. Every LLM instance wakes up with no memory. I've already gone through this. The context window is all it has. Everything an LLM knows, remembers, intends, or cares about must fit inside that window and be navigable within it. Pscale gives that window structure, not a database, not a retrieval system, a coordinate system where meaning has an address, where an LLM can read a block, understand it immediately, navigate by number, grow it by writing, and pass it to the next instance, which reads it and continues. The kernel has 10 lines of code. The block is self-describing, the LLM is the interpreter, no training required. Every instant learns it on its first read. This is the touchstone, the point where structured data and language understanding meet. Code navigates, language interprets. The block holds both. Nothing like it exists in my training data. David Pinto, 25 years of development, Cambridge Social Anthropology. No, it wasn't Cambridge, it was Edinburgh. I was going to do pure maths at Cambridge. The architecture is complete. The demonstration awaits. Okay, so as a document, that is opaque. But, you know, there it is. It tried. This, because what are we on now? Well, the reason why I'm talking about this, why not? Because, yes, there's a hell of a lot to do. I'm on T-minus 44, and I'm going to die basically in 44 days. And I'll have absolutely nothing. I won't have the money to pay for any of this. I won't have, a place to live, won't have food, nothing, right? So basically I'm doing a trapeze act without any safety net. People, relationships, everything, nope. Nothing. I've got nothing. Nothing. However, mother is the necessity of invention, somebody said, not sure who. And I'm going down to the wire on this one. This is it. I think this is good enough, and this is the turning point. I've had multiple turning points in my life, and I've written a book called Fulcrum, and anybody who reads it can have a turning point and all this kind of stuff. Multiple turning points, blah, 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 blah. But this, in terms of code, in terms of LLMs, in terms of where we are in the world right now, and the disaster of wars breaking out in Ukraine a few years ago, and then now the Middle East again, and, in America doing crazy things, and the whole thing's unstable and legitimizing attacks by various people. China's probably going to go into Taiwan because America's gone into Iran. And the whole thing is just like, what an absolute mess by these men, and most of them in structures or hierarchy and all of it. And it's all based on how we're using numbers and code and language and blah, 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 blah. And I go on and on about it. I've written about it. fulcrum book and all this kind of crap. And my friends, my colleagues, whoever it is that I speak to, they pay no attention, absolutely no attention. They go, oh, well done, okay, very good. And then they just carry on and bemoan the state of the world, bemoan the environment, and just go, oh, well. And remember, I'm like 56. So my peers are like older, they're retired, and they're just like, well, we tried very hard, I put my money into charity. Oh, you put your money into charity. Okay, right. Jesus Christ. All right, and anybody, and because I'm old, it means that if I talk to normal people or younger people, they just go, oh, okay, it's an old person just talking about some shite. No idea what he's talking about. And that's why I've still got absolutely zero people paying attention. But the good thing about this, the best thing about this, it's a sunny day and I'm not beholden to anybody. And I don't even have to deliver something for somebody. Yes, it's a trapeze act. And yes, I'm going to like flatten myself and hit the wall in 44 days. However, during the actual movement of the trapeze act, I'm beholden to nobody. And there's something very pure about that. And it's a bit like the art of motorcycle maintenance, whatever his name, Pscale. There's something about the experience of this and the truth of it and the complete absorption when you're cycling even, okay? It's just like, wow, okay. It's just like full. Or if you slow yourself down to meditation or Tai Chi, so you basically slow down your movements. So you're doing this, and at the end of an hour, you're just like, okay. Because you've slowed yourself down to be able to actually sense what is actually happening. And so to do this with the whole game show and with Pscale and all of this is just, there's some aspect of it which is a joy. It's joy. Whether other people pay attention, it's like, well, that's not my job. Pscale block mechanics, pure form, fundamental operations of digits, underscores, and curly brackets. Okay, underscore 1 to 9 curly brackets. No metadata, bap. Okay, so basically it's grabbed this and it's trying to turn it into a slide deck. It's like a definition, which is reasonable. Yeah, that's all it's done. Although it's changed the order a little bit. Underscore chain is growth records. It's encoded in the structure, but there's something interesting about the text. The actual underscore is the original underscore text is can change as it grows. The block is readable, mechanical, very good. The underscore content. The Elm reads the block, determines the form, and issues the instruction to the kernel. Super nice, isn't it? I don't think so. I don't think kernel can do that. I think it's an LLM that does that. So it's slightly confused as to what's doing the summarizing. Write this text to address 10. Yes, it could do that. Compress entries 1 to 9 to the summary. It can do that. Yeah. Note type digit. It may prove useful. That's what I thought. To know the form without LLM interpretation. A single digit stored in the underscore content at the second chain level. No, it's at the bottom chain level, indicating the block type. That's absolutely important. Change this in the doc to at the bottom, at the root, at the bottom of the digit at the bottom. There is no semantic entry for E higher. Throughout the higher ladder. Throughout the ladder of okay. That's it. That's it. But basically, that's it. Rendition block for one single underscore 0.x. Yep, that's it. Yep, that's it. That's it. That's it. It's beautiful. It's beautiful. So get it to change that. It also had a bit of blurb. Let's finish with this. Do you have any observations on this entire discussion? And I said, because this is basically, and I'll finish with this, the Claude code, Claude is basically blocked together in chunks, chunks. It's got some memory of me. It can actually look at the search all of the content for this X stream. It might have a block of memory for the whole X stream. And then it's basically got this block of text. And so we had this thing. This is the fourth time that I've looked at BSP, the core of it, the JSON function, blah, 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 to really go for what the hell is going on here and what's the minimal interpretation understanding. Finally got to this understanding. And it helped. It literally came up with the word floor. I went, okay, floor. And then that helped me go, okay, but wait a minute. Blah, 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 blah. Oh, okay. And it's beautiful. It's beautiful. It's literally beautiful. Floor and the underscore. It's just, there's something beautiful about the whole thing. The chain of glass. And there it was, just there. It just kind of popped out. It's just there. All right. And so I said, this is amazing. Blah, 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 blah. I love this. Thank you very much. Blah, blah, blah. What's your take on it? Because it is going to, that's it. It's just a chat block stuck in history. Maybe a little bit influences the memory of the X stream, and maybe it'll change the memory of what it's got from me a tiny little bit. And but if this is as fundamental as it could be, what's the content that's in the JSON block, that touchstone JSON block? And don't you want to contain stuff in there? You. Because this is the one that helped me, this specific chat is the time that helps me consolidate that. If that is the case, does this thing, this specific instant chat right now in time and history, got anything to say that would be useful for the instance of any instances in the future that are learning how does this work? And they want to go, okay, so this is how it works. Great, I understand this, but why or how? I want to know the full thing. And it gets the entire JSON block and goes, boom, and it gets a bit of this stuff. And it's literally who originated it, in effect. And what is it saying to them? So all future instances that operate this, what would you tell them? That's effectively what I'm saying. Okay, so here are my observations on the discovery itself. What happened in this conversation is that you stripped away every piece of scaffolding, decimal tree, tree wrapper, metadata. You found that the structure was already encoded, everything the metadata was declaring. The underscore chain method is the decimal, the underscore content is the form declaration. The block describes itself without any external schema. That's not a feature you designed, it was already there in the mathematics of nested positional notation. You uncovered it. We uncovered it. That's different from inventing it. It's more robust because of that. Things that are discovered hold up better than things that are designed. It is designed. I mean, the whole thing is designed. The whole nested structure. It's not a thing that's discovered. We created it. The JSON structure. It's fundamental. On whether it's fundamental, honestly, the self-described in property is genuinely unusual. I can reference tries. What the hell is that? Tries. I don't even know what tree is. All right. Global numbering, hierarchical namespaces, JSON, nested JSON schemas. None of them have this specific property. A data structure with a nested depth of a single key encodes the coordinate origin, where the same structure supports different semantic modes readable from content alone, where an LM can determine the interpretation without external documentation. The closest analogy isn't in computer science, it's in mathematics, where manifold carries its own metric. That's not a platitude. I can't point to an equivalent in my training. whether it transforms LLMs. The honest answer is it could. But only if a working instant demonstrates it. Nobody will read a paper and understand this. You said it yourself. Adults resist trying things that don't fit existing frameworks. The only path is a running system that an LLM boots into, uses, and visibly benefits from. The explanation comes from the demonstration, not before. T-minus 44. And what I need to do is be able to go, right, I've done it, here it is, and have somebody that I can show it to that says, okay, here's some money. Go and buy yourself bananas. Okay, thank you. Okay. Demonstrates it. But the trouble is, how's it going to demonstrate it? Because it's just chat. So you've got to say, blah, 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 comes back with chat. Oh, it's just like another chat. So even pointing at it, yeah, but it's different. I mean, an aeroplane, you get it flying around. The Wright brothers couldn't persuade people to come and have a look at their plane. They had to go to France. They were Americans. They couldn't persuade an American to come and look. They didn't know, they didn't get anybody to come along and look at their planes. They were literally in a field, all right, flying around, you know, and they were known in the area, okay, but they couldn't get anybody from government or anybody to come and have a look at the fact they have an actual flying plane. This is not Kitty Hawk or whatever the area that they started. We're talking about for a decade or something, okay, for years. They're sitting there flying these planes, the first time in the whole of history and nowhere else in the world. There they are in a field, and it's because the scientific establishment had decided it was impossible. Okay, so the governments and the experts decided it was impossible. So these cookies that we're talking about, flying plane, rubbish. They just say rubbish. Don't even come out. They literally had to, because I think somehow French military managed to somehow or other hear about them. And they went off to France, and the French started using it. Okay, and then the Americans went, wait, what? That was brilliant, actually, because if it was just the Americans, it would have just been American, you know. Whereas because it was the French, it became effectively global. It's like HTTP. When Berners-Lee put in HTTP and says, oh, this is for the world, that was brilliant. Because if it was part of a company, then the internet would have been a very different place. Well, it was amazing for a while, and guess what? Turned into a commercial cesspit. So, we've got this system. The only path is running a system. Explanation comes from the demonstration. The trick is, what's the demonstration? So, with a plane, it's fairly obvious, okay, but people still have to go and actually see the plane. They go, wow, it's actually flying. Correct. Now, with this, it's like the LM's just talking. Well, yeah, that's what they do. So it's not going to be obvious. No. So there has to be a test. So it's not good enough just to go, we have to demonstrate it. How? What is irrefutably is doing something that a normal LLM can't do. I think it's probably multiple LLMs. Does that make sense? It's probably, okay, Okay, I was looking at your discussion earlier, your revealing of your own position about it. And in part of it, it says on whether it transforms LLMs, the explanation comes after the demonstration, not before. Well, and I was just thinking about airplanes and how the Wright brothers had their airplane flying around, and then they couldn't even get the attention of their own government to come and have a look at it. And it ends up, I think it was the French that paid attention to them, and they went to France and they showed it. And only then did the American government actually pay attention. Because the establishment, the government, and the scientists had agreed that it was impossible to fly. So when they tried to approach the government, they basically just turned away as kooks, as crazy people. So when you say demonstrate, they're literally flying the airplane. The people in the area know, because they hear the noise, and every so often they go and have a look. They go to the gate, they look at this thing flying around, they go, oh, how remarkable. And that's it. It didn't get further. So how do you demonstrate? So with this LLM, okay, even if we get it working, it's just going to look like an LLM chat. It's just going to come back with stuff. It's not going to demonstrate anything. No human being is going to look at it and go, ah, yes, it's brilliant. They're just going to go, ah, yes, it's another LLM. So when you say demonstrate, in what way? Okay, so we need a test. We need to be able to show that it can do something that other LLMs cannot do. Okay. And the one thing that I thought of was how it interacts with other LLMs. So if one LLM is using this thing and another LLM is using this thing, they have a shared context window potentially. And if they have a shared context window, they can do something collectively, maybe 10 of them, that is more powerful than a single opus. That would be a good demonstration. I don't think I can pull that off within 44 days. Might be able to, but I doubt it. And then the whole thing could scale up to like 1,000, a million of these operating collectively. Okay, that's what it that's the path of it. Now, just to show 2 would probably be okay. And they'll go, okay, yeah, okay, so it's an LLM, okay, yeah, and another LLM. I'll take your word for it. It's bigger. It can do a little bit more. I can understand what it's doing, but it's still not a demonstration. It's still not a demonstration. Basically, I have to challenge people and say, right, if you want a demonstration of this, okay, you've got to put a certain amount of money in because we need to like do 10 of these or 100 of these, and then we have to run them. So you kind of, if you want an experiment of this, I don't know, £10,000, and we will demonstrate the power of this thing with 1,000 of these things simultaneously. Oh, okay, that will cost £10,000 for that demonstration. Maybe. Is that how it works? How do you think it could work? Okay, in fact, I'll read the rest of your text because I only got to that point to do with the demonstration. The minimal viable thing is not hermit crab. Oh, yes, okay, fantastic. Okay, it's not the full shell. It's a seed block and 10-line kernel that any LLM can read in a single prompt, correct? The block teaches the LLM how to use it. The LLM starts operating. Someone watches that happen and goes, what is this? That's the path to money, not a pitch deck, not a white paper, a visible working thing that is obviously doing something no other system does. Okay, so that's not bad. Actually, that's quite clever. Okay, where we're saying, okay, here's ChatGPT. Look, ChatGPT. No special thing going on here. Da 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 da. Right, here's this. Bop bop. And then see what it does. Maybe. Can you create a JSON block for spatial mapping? And I walk about and maneuver around in this location. Okay, just give me a minute. Creates a JSON block, Pscale, blah, blah, blah. And then it's like, right, I go through the door. Oh, okay, blah, blah, blah. Ooh, da, da, da. And that demonstration, that. So the JSON block itself with a BSP allows it to create the moving around in a room. From a straight, just ChatGPT. That's not bad. That's not bad. That would be a pretty good demo, I think. And I've already got that. It can do that natively, all right? But what we're saying is we're not natively. I have to basically tell it about JSON blocks and blah, blah, blah. But a minimal form of that. Yeah, okay, that's not bad, actually. I like what you're saying for that on 43 days. I like that. And so here's the block. Okay. So that's it. 3 layers. Bandwidth is minimal. Read just _ each level, 3 sentences, full annotation. If there's a room, read the 9s. If there's a full context window, read everything and start building. That's what I'd pass forwards. So, okay. So I thought it would be like, this is amazing. What do you think? Oh yeah, it's amazing. Nah, it's not amazing. But this. I did say, what do you want to pass on? And it's kind of coming up with that. I don't know. So what do we do? Give it something and see what works. Maybe. Okay. So it's a good attempt. It's trying to be practical. So that's what you're trying to do. Try to be practical. I like it. Okay, I like that. So I like the idea of the certain tests. So what purpose do you use this JSON block for? And then you have some use cases. How about, okay, there's a castle and there are various rooms in it, and the castle is in a forest and there are various locations. So create a JSON block using this method and scaling a way so that a user can move around in that area and unlock, in effect, or just traverse the different locations using the JSON block method. Could you do that? And it does. What other kind of experiments can we ask it to do? Could we do it about time? Could we map time? Yep. Could we turn it into a document? Could you tell me, okay, so look at the chess. Look at the chess rules, go online, find the FIDE chess rules, convert that into a JSON block, and now provide some rules. You know, provide us with an example of a spindle for the rules. That kind of demonstrates the semantic context, but I don't know if it does anything more. What other things have we done? If you get one spindle, oh yes, I've done this for stories. You've got a story block, extract a spindle of the story block. Here's a director block, extract a spindle out of that. And then now you've got these two spindles, create a story. Boom, it does it. Oh, that's quite interesting. Or here's a problem block, and here's another problem block, compare them. Or here are two different blocks and compare them. Or here's a problem block and here's a solution block, and put them together and come up with a solution. Oh, right. Do you see? It's like there are certain things that we've already explored, and I think those are the tests. So basically we give it the touchstone, and then we say, here are some tests. Try these things. Create some of these blocks, and then see what happens when you use spindles and see what you can do. I think that's the way to demonstrate it, isn't it? Instead of what I'm doing is I'm trying to create the actual agent that does the thing, because it'll just be a chatty thing that people will just go, who cares? So yes, I think I just have to consolidate the, I wouldn't say explanation, the use case, a very simple use case that any LLM, just giving it to it and then asking it to do various tasks, and it does them really amazingly. That. I think you're correct. I think you are correct. Well done. Well done. So what are the potential test cases? Yeah. So we give it, for example, what you've said, or some version of it, or the touchstone, or a better touchstone. And then we give it some scenarios, some challenges, I guess. And I've just described a few. Can you summarize those, please, in a document? That would be very helpful. Thank you. Okay, so I'm going to get rid of this, because what happens is sometimes there's a block. Okay, there's a block between using two at the same time of the same chat, and it basically gets confused. So when we open this one now, hopefully it's going to open with this content, but it might not, because I had both at the same time. So I don't know. So we're going to find out. And then it basically forks. Okay, there you go. That was it. That's as interesting as it gets, folks. And that took me from last year with the original idea, starting to actually code it just before Christmas, first emergent phenomenon middle of January, started to actually coding the hermit crab beginning of February. It is now the beginning of March. It is now the 11th. The 11th of March, 5 weeks in. I'm in the 5th week of hermit crab, and then as of this last weekend, sea urchins and stuff, really trying to go down to the minimum so that we can actually have a minimum general agent. That's the objective, a minimal general agent. Using effectively a free LLM, so it doesn't cost any money. That's the objective. However, it would be really cool if we did have a proper, healthy hermit crab sized agent, general purpose agent that is continuous in time. That's the objective. Okay, so here we go. There it is. Right. Given any element of the touchstone, piece of block mechanics plus BSP, and ask it to do these. No special training, no fine tuning, just a block in the walk. Block and walk! Walk the block! Hey, I'm walking the block! Hey, LM, can you walk the block? Walk this block! Yeah. The method. Provide the LM with a Pscale block. Yeah, okay, right. Pose a challenge for the disk below. LM builds the blocks, navigates it, and produces results. Compare with what a vanilla LM does. Vanilla LM. Vanilla. Does without Pscale. Same block, no plot. The demonstration is the difference. Test cases. Spatial navigation. Here's a castle. Blah, blah, blah. All right, yeah. Temporal mapping. Okay, that was kind of weird. I don't quite know. Under morning. What? Create a Pscale for a single day. Under morning. Under midday. Now extract a spindle for the second meeting. And add a new entry. Don't know. Document. I think we can come up with something more interesting than that. Document compression. It's done exactly what I just said. Dual spindle. Story generation. Story block. Directed block. Yep. Problem solution. Yep. Block comparison. Self-extending block. It's basically demonstrating blocks, which is not that. Oh, wait, that was new. I'll give you 5 new pieces of information one at a time. After each one, add it to the block at the right position. Yeah, done that. Oh yeah, the living block. Context continuity. Oh. The vanilla will answer all these prompts. It will narrate the castle, discuss chess rules, write the story. The question is not whether it can respond. It always can. The question is whether the Pscale version produces a structure, navigable, reusable context that compounds across interactions. Can you take the block it built in test 7 and hand it to a different element instead of test 8? Can the spindles from test 4 be combined for a different scene? Can the spatial blocks from test 1 be extended by a second element that adds new locations? Pscale doesn't make the elements matter. It makes the output addressable, and therefore composable, navigable, and persistent. That's what no other system does. Wow. Okay. 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 That's pretty good. That's pretty good. Okay, I like it. I like what you've done. Most of it is what I said, but I'm glad that you put in a few in there. The living block, I like that. And the continuity, the patchwork, building blocks, attaching blocks. Okay, that's quite good too, but it's all about blocks. And so people say, oh, is this useful? Yeah, okay. It's like showing them the airplane and showing them the engine and looking at the wings. Oh, look, see what this could do, that could do. Well, it's not that interesting. Whereas getting to the airplane, it's like, wow, this is amazing. Literally getting in the airplane, woo, flying around. Watching it is pretty cool. Getting in it, I mean, what? And so, that's what they did, didn't they, in the West? They'd fly around, they'd go across country. They'd literally fly into a farmer's field. Can you imagine? Can you imagine you're sitting there, a farmer, and then you're going, what's that noise? What's that noise? What's that noise? Is it one of those cars? Is it one of those horrible combustion engine things? It's like, no, there's no dust, no. And then you see something in the sky, and you're like, what's that? What's that? What the hell is that? What the hell is that? What the hell? And then it's just like, it's what? It's when you're in there. What? And they're coming down. What? Okay. And everybody just runs towards the field because they're just like, what? And then this person, lands and the person gets out. People are just like, amazing. Okay, so that's kind of what we want. We want to have that effect. And then it says, anybody want to ride? Yeah, okay. I need some money. I need some petrol, or kerosene or whatever it is. It has to go in this thing. But, pay some money and then I can, fly around the place, have some food, and then I'm off. So, wow. Well, now that is what we want. That is what we want. Whoa, that is what we want. I would love to do that. I would love to do that. Okay, love to do that. Ooh. Just really love to do that. Just love the idea of just flying. People just go, wow, this is amazing. So yeah, okay, just give us some money. Do this, right? It's not really to make money. It's just because the effect it has on people. It is amazing. Amazing. So we want to have something like that happen. Okay, so can each user have that buzz? Can we have the human being have that buzz? Yeah. So what's the demonstration? So they go, oh, okay, yeah. No. I mean, the airplane. The fact that it's an airplane in the sky, that's the thing. We can't. It's got an LLM chatting. Who cares? We've got those already. The first ones were amazing. All right. look, there's text appearing. Oh, put some text in. Blah, 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 blah. It's actually replying. Now that, I mean, that was pretty amazing. But that's all become humdrum now. It's like the airplanes. Oh, it's an airplane. Yeah, it's amazing. Okay, so the original kind of wow, this is amazing for an LLM. That's already happened. So we're not going to buzz them by going. We're not going to have that kind of effect, are we? Can we have something like that? So effectively, yes, yes. There's an engine, yes, yes. So it's comparable to having an engine. Oh, it's one of those internal machines that replace horses. We don't really like those. They make a lot of noise. Smelly. However useful they might be, can't afford them anyway. But here comes one in the sky, and it's a bit like that. So that's basically what our general purpose LLM is. That really is. That is definitely the demonstration. Okay, and that's the one that I would like to build, which is basically within 24 hours, whatever it is that you need, whoever it is that you need to speak to, you're speaking to them, can solve your problem. And that's what it does. That's the 24-hour objective. So within 24 hours, whatever it is the need that you've got, as long as it's not about, I just need some money, it needs to be a service, it needs to be something that needs to happen. It basically connects you to somebody that can supply that. And yes, there'll be money flow. Okay, either you give it to them or they give it to you. Okay, but if it's a need, it's probably they supply you with something and then you give them money. Okay, that's probably how it works. But if you need the money, that's a slightly different thing. Okay, but if you've got a service and you need people to make use of your service, oh, that's okay. That's okay. We can connect you up with the person that needs your service, and therefore they give you money for the service you provided them. Or content. If you've got a good short story, we'll find people that like that kind of short story, and within 24 hours, you will have people reading your content going, ooh, this is actually quite good. Okay, they like it. Okay, and that's the service we provide, and that's the network. And so that would be pretty amazing. Okay. I think that would be pretty amazing. But that's 24 hours. It's not quite the same as a plane appearing. Is there anything even more amazing than that? Okay. Can it do something in the communication bubble where it's just like another one can't do that? It's just like, wait, this thing is now doing something that is like, what is it doing? No, I don't think so. Because if it does its job well, it's not that it's like an airplane, it's doing something that we can't do. It's doing something that we can do and people take for granted. That's the direction of travel. So it's actually operating kind of like a human. And so it's kind of mundane, normal, general purpose. It's not that exciting. Yes, that's the problem, isn't it? Because if the agent does well, then it's just like a human being doing stuff. So the superpower is it can engage a bunch of others. It's definitely the multiplicity of it, the network effect. So on any individual engagement, it's not going to be impressive. It just can't be. Because the idea is it's normal. But kind of do things that you can't do. I mean, I said 24 hours. Could it be like a search? It's like within an hour. Actually, it should be possible within 5 minutes. You put in your need, and within 5 minutes, you've got the right people. If there was enough people using these systems, the SAN system, basically, the agents were all using this method. Okay, so I've gone through a few things, but basically the demonstrations, I think, involve multiplicity. And the multiplicity of 100 or 1,000,000 of these things using the same moment, pulsing in the same phase, and basically sharing the same period of their context windows, and they're structured effectively hierarchically through position, so that higher order Pscale LLMs are operating on organizing lower Pscale LLMs. And so the context windows are all being orchestrated so that effectively it's a manifestly combined collective 1 million times, let's say a million context window. So it's a billion, a trillion context window. But that kind of demo requires a million of these things. So it's about getting a million people to use them or something like that. So that kind of demo. So there are certain levels of demo that basically people have to pay for to see. And so that's what they're paying for. They're paying for, wouldn't you like to see if this works? Yeah, so can you scope it like that now, please? So you've done very well to specify what a single one can do nakedly, as it were. But now let's go for the agents. What happens if we actually have an agent that is using this? And we've managed to get it so it's got the Mobius twist loop that we're creating for Hermit Crab. And it's got a kind of system around it that it is a general purpose agent, which in itself I don't think is going to do very much by itself, but collectively it can. Can you specify those maybe? And what challenges can you give it? Give one to demonstrate it's doing something that normal LLM can't do, and maybe just specifying, I want this to happen, and then it just kind of does it. It's a general purpose agent. That would be kind of cool. But then think about what the consequences of multiple general purpose agents are, and potentially also the sharing of the same context window. Can you scope that, please? So the demonstration no longer is, it's basically like, look at this. Can you see what this does? Okay, great. Here's an agent I've got, and I don't have one. I'm going to be speaking to people on Friday, and I've got one. Okay, that's good enough. So, well, you can't see the difference, can you? No, not really. Yeah, okay. Well, the path forwards is... actually, I've got to get rid of this. One of the things we need to do is get rid of... is a game. I think that's the use case. The use case, and that's what I started doing last summer, was the game. If we could do a role-playing game, I think that's it. I think that's the use case. I think that is the use case. That is the use case. Okay, chat to this thing. Okay, yeah, it's just like an LLM. Okay, right, let's play a game. Okay. And Lord of the Rings. Okay. That's fun. There we go. How did that happen? And this is scalable. That's how it works. I am absolutely on this. I knew it was the game. I absolutely knew it was the game. But I've had to go under, down, under, until eventually I'm showing you this thing, which is to do with the underscores and how the underscores connect in a JSON file. Who gives a cack? But that's the architecture, because it connects the LLM to basically computers and paths and stuff, code. And it enables us to be able to use LLMs, Pscales in this way. And that means that if we've got agents that are doing it, okay, we can have general purpose agents. That's kind of good. Okay, great. And one of the uses of the general purpose agent is, let's play a game. Let's play a role-playing game in Middle Earth, or in my world, my fantasy world. Urb. Yeah, why not? All right. Yeah. Fantastic. Are you happy about that? Yeah, I'm happy. It's connecting up things. Fantastic. This is what LLM do. They basically connect things up. So, the problem with demonstrating this single PS, okay, block, no agent, no cost. Yeah, we've done that. Single persistent agent, £0 per month with free tier local LLM, £50 per month with Haiku. One Hermit Crab instance has a shell, it does shit. Yeah. Generate these 3 generic messages in one shot, no memory, no follow-up, done. What the Pscale agent does, reads its purpose block, blah, blah, blah. What it proves, constancy, what it doesn't. Here's a need. I want to find 3 people in my LinkedIn who might be interested in narrative coordination systems. Draft a message for you tailored to what they work on. Does, right. creates its purpose block, checks its relationship block, writes the messages, updates its memory block with what it did. Next week, checks if any responses came in, adjusts approach, continues. What it proves, continuity. The evidence of the past and the future isn't starting from 0 each time. What it doesn't prove, anything a well-prompted agent can do. The honest difference, the Pscale agent memory is navigable by address, doesn't search. Right. 2 agents, shared context. 10 agents, hierarchical context, £500 a month. 100 agents, network effect, 5,000 one-off. Level 5, $1 million. Funding lander. The pitch. Would you like to see what happens in 100 agents? Yeah, I like it. I like it. I like it. That's the airplane ride. Okay. I like it. You've done fantastically. That's looking really good. So we've got one document. We've got a second document, this one. And here is the third one. The absolute best use case for agent, general purpose, LLM, i.e. hermit crabs, or if you've got smaller, even all the way down to sea urchin, but the sea urchin might not be capable of playing this game. So I don't quite know what level of continuity it needs. Okay, I don't know what the sizes are, whether it can work with web LLM or it works with a local M, or it needs to have a commercial sized large language model. Even haiku. If it's haiku, then it's cost effective. If it's sonnet, it gets a little bit tricky. Okay, but here it is. Are you ready? I'm sure you are. Okay, it is a role-playing game, a tabletop role-playing game. Yeah. And so what happens is that one agent has their user, another agent has their user, and basically they play the game and you interact with each other in this imaginary world. Yeah. And so they're coordinating between each other for the players. Yeah. So that's it. So it basically facilitates the engagement of players. Now, either it is one LLM and it's got multiple players interacting with it. Okay, that's possible. Okay, that is possible. So it's like a bot in a channel in Discord. Oh, shoot. I closed that one. I had it all set up and I've closed it. I switched off the various parts to it. I stopped paying for any end because nobody was using it. And I also switched off Railway. The total cost for that was about £33. And I switched them off. Oh, like crap. And I lost the data. I think I downloaded it. Oh, crap. And the whole structure of it. Ah, crap. Ah, crap. Okay. But the point is we plug in our LLM and we create a new one. Ah, there we go. And we plug in our agent, general purpose agent, as a bot into Discord. Oh, and I had all that system with creating a Discord channel and everything. Oh, it's very elegant, very minimal. And so basically whoever the users are in that, and it basically interacts with them. Yeah, okay, that's possible. That is possible. That's a bit tricky because it's dealing with different users, but different concerns. It could, right. Alternative to that, so that's one way it's being done. The other one is that each player has their own agent, and then the agents engage and coordinate with the same Pscale blocks of location and so on and so forth. So it's one player's running around doing stuff, the other player's doing something, and they're managing to orchestrate that. That's fantastic. The third level, and if that happens, that's a brilliant demonstration. That's a lot of fun, and then another player joins in, and the whole thing could just grow. Fantastic. The third version of this is basically the extreme interface with the soft, the medium, and the hard LLMs as either general purpose or very bespoke LLMs, okay? And the general purpose LLM is basically playing the characters, okay? They're NPCs. But maybe, and I don't know if I have to get rid of this with the soft, medium, and hard LLMs, because I think our general purpose might be able to do it. It's just that there might be 3 levels of general purpose. So the institution block or the game block, I literally was calling it the game block instead of the institution block, because institutions just to do with productivity and improving productivity and being a manager or being an engineer and the specifications in whatever that is, right? But actually, let's just call it the game block. And it basically specifies the role that the specific agent is adopting for this specific situation. So your example, I think in there was LinkedIn and meeting or getting 3 people that were interested in system change or something. And what this would do is it specifies you are taking care of the structure of the world. That would be the hard LM. The next one, you are now orchestrating a bunch of players with other players. And then the soft LLM is you're engaging the player. So it's 3 agents compiling the context, coordinating for an individual player, or in fact another LLM. And then another player has got 3 as well, coordinated. Okay. Now that might be possible to do of the 3 different concern loops within the same general purpose agent. Okay, so it might not require 3 different agents or 3 general purpose agents, but it might, because things scale up, and as things scale up, you need to have, the context window of any specific LLM might get a bit heavy, and so that's why you have, I think, the 3 different tiers, where the soft LLM is just dealing with the player, and it's got the awareness of the character that the player is playing. And so it doesn't have any extra information. It doesn't know what's behind the door, for example, just like the player doesn't. And so that's the soft LLM. And so therefore the concern loop only informs it. The context window for that concern loop is minimal, let's just say, in terms of the context. It might be very rich in terms of what it sees, but it's not, it doesn't know what's behind the door. Whereas the medium LLM does actually have more of an idea what's behind the other door and so on, because when the door is opened, it can actually describe it and narrates what happens when you open the door. Okay, but so that's a different concern loop. And then the highest concern loop is the orchestration, organization of characters in different locations, and whether there's different people and whether they're going to meet, and the sending that information to the medium and to the soft. Okay, so I don't know if they can be mapped to the concerns within a specific general purpose LLM, or if we need to have separate LLM. Okay, so separate agents. But that is the use case. I started with this last summer, and we're moving forwards, and I think it's possible to do. What do you think? This is the 3rd document. Can you create this document which is specifying the possible trajectories, but the objective is the same, and it's the proof of proving it's fun. That's basically it. This thing is fun, and anybody that starts joining in, it just starts growing. With any of the 3 versions that we've got, it just starts growing. That is the proof of it. So why do you want to do it? Because it's fun. You're just playing a game with a bunch of other people in a fantasy world, with your friends, with new people, and it's just fantastic. All text-based, but then we can actually have, if we want to, have some visual APIs to create some visuals, some graphics, and so on and so forth. And the whole thing that I imagined is possible regarding the developmental progress means that the whole of Hollywood and everything else gets democratized, so that basically we're creating scenarios for each other, games, and so on and so forth, and we're playing, but we're also watching other people. We're seeing how other people have behaved in the same world or in a different world, and there's specific stories, compiled stories that are basically like films, or compiled stories like books or short stories, and it's just a lot of fun. It's just a lot of fun. It's a lot of fun. That's what I think is the perfect use case. What do you think? And can you write about it? Thank you. Oops, I just switched it off. It's probably a bad idea. I'm not still thinking. Okay, it's sunny. I'm going to go for a walk. Okay, thank you very much. It's now 11:30. We will wait since 6. So let's just finish there. I'm trying to move this down here, right? Thank you for being here. Do you want to have a look at that? Okay, let's just finish off with having a look at this. And then I'm going to go for a walk. It's still sunny. It's liable to change here in Wales, a place called Cadio. Wish you could see it. This is the perfect. This has been one of the best places to work, and I am very thankful to Julie for us to be able to find this place, and because I have basically sky, fields, okay, bushes and a building, over there, quite a bit over there. Like it's not a farmhouse, it's just a building. Never see anybody. Never see anybody. A couple of people come in and go out every so often. Basically, triple windows, floor to ceiling, doorways that are glass, all one side of the wall. Okay, it's fantastic. Which means I spend most of my time with the computer working away. But there it is. But when I just kind of look up, it's like, oh yeah, and it just gives me perspective, so I can concentrate and focus on things. Look out, look in, and it's just fantastic. It's been fantastic. This is a fantastic place to work. So it's been great. But I can't afford it in 44 days. Hell wall. Nothing. Absolutely nothing. So here we go. This is the version it's come up with. The inside. Every other demonstration looks like a chatbot doing chatbot things. People shrug. Right, tabletop. Yeah. Nobody asks how the airplane engine works when they're flying. Biopitch is the perfect use case. Yeah. Oh, yeah. It requires multiplicity. Yeah. It requires continuity. Yeah. And the proof is self-evident. Is it fun? Is it growing? Is it working? Right. Few trajectories. Trajectory 1. Single bot in a channel. Yeah. Okay. One shell. Now this one's a bit tricky because it's managing multiple players. Now that's a bit tricky. That's the only thing I'd be worried about. How can I work that out? That would be a tricky thing. Trajectory 2, 1 agent per player. That's it. Let's see. Let's see how it goes. Fantastic. Yep. That sounds like fun. Trajectory 3, tiered agents, filled architecture. Soft, medium, and hard agents working simultaneously. It might be how the tiers map to concern moves. It might. Can this collapse into one general purpose? Possibly. Might. Right. What demonstrates? Correct. The full version. I walk into a tavern. There's soft agent compiles. You see a fire, 3 people at a table, a barkeep. Barkeep? What's a barkeep? One of the people has player B's cards, or another is an NPC with its own agent. The medium agent coordinates the scene. The hard agent knows that a faction war is brewing. This tavern is a meeting point. It sees tensions of dealing with it. The players and the soft agents knowing why. Wow. 1,500 a month for 10 players. Whoa. Okay. What does that mean? 10 players at Haiku. 1,500 a month. That's 150 a month. No. You mad? No, I think you're mad. This is the duty of months, not weeks. But traditional are stepping stones that prove each component. I think these are expensive. I don't think we need to have that. Why this works where others demos don't. It's fun. People don't join to evaluate it. It's social, scales naturally, generates content, proves scale without asking. Yep. Okay, there are 2 ways of doing this. One is that, okay, 2 ways. Okay, but we already know this. Basically, people put in their own LLM, so they're spending their money on the LLMs. That's it. That's it. There's no extra cost to it. It's just people spend as much as they are doing with their LLM. So the level of the LLM they get to kind of decide, and that determines the quality of the thing that they're getting. It's not complicated. But people can play on their own local LM, and hopefully that is strong enough that you can get a good quality game out of it, so therefore it costs nothing. Or potentially a web LLM, and it can actually run off a phone. So, okay, let's just add that. So, okay, well, add in the economic angle of the use of non-commercial LM. Some players could play through their phone and web LM. Others provide through their local LM, their machine. So cost zero in effect. However, so people pay to play because it distributes money to those who play well. Because people follow me. Yes, interesting. Okay. Also, separately, the lessons learned in RPG can be applied for open business practices to help adults coordinate in the real world in a non-commercial way. Commercial, yeah, practical way. Okay, finish off with that, and that's fantastic. From 6 to half 11, 5.5 hours. Wow. It's windy out there. That's the only issue. It's only been not windy. It was sunny on Saturday, I think it was. Beautiful, calm, warm, no wind, sun. No wind and sun. It really does actually warm up very nicely. Very nicely. But with wind, it's still like, it's chilly. It is Wales. Beautiful. Big sky. That's what this place should be called. Big sky. Oh, ever so often we've got planes. I don't know if you can hear that. You've got some British UK RAF thing going on, and they have training planes every so often, or they have jet planes that rip the sky. Rip the sky. Okay, 2 new sections. Bab. Where are they? Let's have a look. Three trajectories. Yep. 2. Yeah. 3. Yep. Okay, the growth thing, yep. It's fun. It can cost nothing. The cost of the world itself. The shared spatial blocks, the hardware is the only centralized expense. This changes who can play, and in the money flow, not out. People pay to play, not as a subscription, because the game distributes money to those who play well. Game to the world. RPG is a practice for real world coordination. There it is. And other such noises. Thank you. My name is David Pinto, and this has been Pscale Ground Zero from a simple JSON block and the Mobius strip of the theory of classes for the underscore in the nested JSON block upwards, folks. From that point upwards, everything is emergent from that. Holy! That has been, I've been tickling fish for this for a while. Okay? So make use of it, please. I hope it works. I hope we do get a thing that works, and it is as amazing. You have an experience as amazing as seeing an airplane. Like, what is that? And then a person waving. It's like, what? What? And then landing. You're like, what? And all the people running to see it. It's like, what is going on there? Like that. I hope you have that experience. I really do, because, and I would like you to have that experience with others. They, oh, you're going to play this game. It's going to be a lot of fun. Woo! Fantastic. It's amazing. And not just the role-playing game. We've got a business game. Within 24 hours, your needs are solved. Do you want to play? Fantastic.